Hello, this is Satbir. The topic of our discussion in this video tutorial is the third counting principle, which is subtraction rule. The subtraction rule of counting is also known as the inclusion-exclusion rule. We use this rule if a task can be done in one or two ways, but some of the way to do it are common to both ways. So basically, to remove the doubling when we perform the procedure, and we are performing the two tasks, and the two tasks has some doubling in it. To remove that double counting, we use the subtraction rule. In order to have better understanding of this rule, let's practice this rule with a few examples. Our first example is how many way can you pull out one card which is either a king or a heart from a standard deck of cards. To begin with the solution, first I will underline some keyword. As you can see, my first keyword is I have to pull one card. Either it can be a king, that is the second keyword, and the third word is can be a heart. So these are the few keywords of this problem. So first, in order to synthesize this problem, I will draw a diagram. In the diagram, I will write down what is the procedure. The procedure is we need to pull one card. Then we write down what are the events. So as you can see, there are two events. We need to pull a card. It can be a king or it can be a heart. So there are the two events to perform this card, perform this procedure. And the two event has a conjunction or. Either you can basically pick a king or you can pick a heart. But in this procedure, notice there is a common way to perform these two tasks, and that is that a king of heart. So when you are pulling out a king, you can also pull out the heart, or when you are pulling out a heart, you can also pull out a king. So this is a common way which is exist or which belong to the both the task, so which we have to remove this doubling. So therefore the total number of way to perform this procedure, the total number of ways to pull one card will be, so how many way we can pull out the king, because there are four king in a standard deck of card, so there are four this way. How many way we can pull out a heart? There are 13 ways to pull out a heart. And how many ways we can pull out the king of heart? And this is the one way, because there is only a one card which is king of heart, or there is a one card which is a heart of king. So therefore the total number of ways will be 4 plus 13 minus 1, because 1 is the common way to do these tasks, and therefore this will be a 17 minus 1, which is equal to 16. So the total possible ways to pull out one card, there is many possibility, will be 16 possibility. Let's take one more problem where we will use the subtraction rule bit differently. So first we will read the problem and underline few keyword. So as you can see, the problem is each user on a computer system has a password which is a 6 to 8 character long. So it can be a 6 character long, 7 character long, or it can be a 8 character long, where each character is either a upper letter or a digit. So for the each character you can use either the letter or you can use either the digit. Each password must contain at least one digit. So there is a restriction here that the password must contain at least one digit. How many possible passwords are there? So basically we need to find out the number of password which we can create. So first I will write down what is the procedure in this example. We need to create a password. It is a 6 character long, or it can be a 7 character long, or it can be a 8 character long. So this is the procedure. So password can be a 6 character long, 7 character long, or 8 character long. So in order to complete this procedure, I need to perform the three tasks, and these three tasks will be: the password is 6 character long, password is 7 character long, and password is 8 character long. And also you can see the conjunction. The conjunction is or, because either the password can be 6 character long, or it can be 7 character long, or it can be 8 character long. So you cannot have like the password which is 6 and 7 character long. So either you can have the 6 character long, or you can have the 7 character long. And there is no commonality between this. So we can just use the addition sign to calculate the total number of password. Now next I need to calculate how many ways this event can happen. So, or in other word, how many way I can create a password which is a 6 character long. So I need to create a password, or I need to fill 6 position of my password. So these are the 6 position. So let's see how many way I can fill the first position. So in the first position, I can use either the uppercase letter or a digit. So their total number of way 36. Second position, I can use also 36, either a uppercase letter or a digit. The second position can be filled 36 way, and third, fourth, fifth, and sixth. So there are 36 way to fill all these six position. So since I have to fill all the 6 position, there is a conjunction and in between all these tasks in order to generate a password of 6 character long. So there are 336 to the power 6. This many ways we can generate a password which is 6 character long. But now there is a restriction that the each password must contain at least one digit. But here there must be a password which may not have any digit, which contain all the uppercase letter. So basically we need to delete all those many password which contains only the letter, uppercase letter. And as you can see, there are 26 uh, letter in the English alphabet. So 26 to the power 6. So this many password will contain only the uppercase letter. So these the number of password which generate from using 26 letters. 26. The number of password only contain letter. So these are the basically the repetition which we need to exclude from the total number of ways to generate the 6 character long password. So this will give us basically, if I calculate 36 to the power 6 minus 26 to the power 6, this will gives me the total number of way a password which is a 6 character long, and each character will have at least one digit, because we remove all those number of way which contains no digit or which contains all the letter. So the number of way which we left out of 36 to the power 6 minus 26 to the power 6, these are the number of way which will contain at least one digit. Or can similarly we calculate how many password will be there of 7 character long which will contain at least one digit. So this will be 36 to the power 7 minus 26 to the power 7, and this will be 36 to the power 8 minus 26 to the power 8. Therefore, if I use now the addition rule, so I can calculate the total number of password. So our total number of password will be by using now the addition rule. So this can be 36 to the power 6 minus 26 to the power 6, and this will be 36 to the power 7 minus 26 to the power 7, and this will be 36 to the power 8 minus 26 to the power 8. This will be a very large number if you calculate, and you can calculate by using your computer or a calculator. So I have calculated this number, and this number is 26848306330. So this many passwords you can create, which are either be 6 character long, 7 character long, or 8 character long, and each password will must contain at least one digit. Here I have one quiz problem for you to practice. Please pause the video for 1 or 2 minutes and work on this problem. Our next example is in a version of computer language BASIC. The name of a variable is a string of 1 or 2 alphanumeric character where uppercase and lowercase letter are not distinguished. Moreover, a variable name must begin with a letter and must be different from the 5 string of 2 characters that are reserved for programming use. How many different variable names are there in this version of BASIC? Let me read this problem again and underline few keywords. So in a version of computer language, the name of a string is 1 or 2 alphanumeric, means either it can be a letter or a digit, that is means the alphanumeric. Moreover, a variable name must begin with a letter. So this is another keyword. So the password must begin with a letter. Must be different from the 5 strings. So there are 5 string of 2 character long, which is a reserve for some programming use, which we cannot use here. So how many different variable name are there in this version of BASIC? So how many variables we can create by having either a 1 character or 2 character long string, where you have this restriction that the variable name must begin with the letter. So in order to synthesize this problem, I'm going to draw a diagram in which I will separate the procedure and task. So our procedure is we need to create a string. It can be a 1 character long or it can be a 2 character long. So if this is a procedure, it means I need to complete the 2 tasks. My first task will be the password is only a 1 character long, and my second task must be that the password is a 2 character long. And there is a conjunction or between them, and there is no commonality between these 2 tasks, because either you can have a string which is a 1 character long, or you can have a string which is a 2 character long. How many way we can create a string of 1 character long? So as you can see, we can order to use the create the string, we can use the alphanumeric, which is either a letter or a digit. But the string must start from a letter, so it means the first the string, which is only 1 character long, only can use 26 letter. It cannot use the digit because it is only a 1 place to fill. But in order to complete the second task, you have 2 places to fill. So 1 place 26 because you can only use the letter, but the second place can be 36 because you can use the alphanumerics. Either you can use 26 or also you can use the 10 digit. So you have 10 more digit which you basically fill the second way. But also there is a restriction that in the second task there are a 5 way which are reserved. So you have to remove this 5 string which are reserved for some programming use. So you cannot use this 5 string. So if I write down the total number of ways, so therefore the total number of string will be 26, and this or will use the addition sign because we will use the addition rule, and this will be a 26 times 36, and we have to subtract 5 because the 5 string of 2 character they are reserved for programming use. So if I calculate this, is going to be a 957, the total number of the strings of the variable can be generated in this basic language of the basic version of this computer language. Our next example is, suppose there are 5 letters A, B, C, D, and we want to use the 5 letter to form a string of length 3. How many strings contains the letter A? Allow the repetition. Solution. Again, I will read the problem and now I will underline also some keyword. So suppose there are 5 letters. So we have 5 letters A, B, C, D, E. All 5 letters are different. We want to use 5 letters to form a string of length 3. So we want to form a string of 3 character long. How many string contains the letter A? So this is basically how many of them contains the letter A. First, in order to synthesize this problem, I will write down the procedure. So our procedure is, we want to generate a string of length 3, or I would say 3 character long. So in order to complete this procedure, I need to perform 3 tasks. The 3 tasks is, how many ways I can place a letter in the first position. That's my first position. This is my second position, and this is my third position. So if I complete these tasks without any restriction, then I will have a 5 possible way. I can pick any letter A, B, C, D, and E and place it there. In the second position, I can pick any letter and place it there. And in the third position, I can pick any letter and place it there. So this is the number of way I can create a 3 character long string by using the letter A, B, C, D, E. So this is my total number way, and as you can see, since I have to perform these tasks independently, so therefore the conjunction between these tasks is AND. Now I also calculate that this restriction. So this restriction is that how many strings, because I need to compute the number of string which contains the letter A. So instead of calculating the number of ways to the number of ways the string contains the letter A, I will calculate that how many ways I can generate the string which do not contain the letter A. So the number of ways which not contain the letter A. This will be easier to use the subtraction rule. Basically, if I first calculate how many strings are which not use the character A. In that contain, if I put this restriction, I will have only 4 possibility. For the first position, I will have 4 possibility of the second position, and I will have 4 possibility of the third position. And again, the conjunction between is A. So if I calculate, this will be 5 raised to power 3. This is the total number of way I can generate a string of 3 character which may have A or may not have A. And 4 to the power 3 is which do not contains A. And if I need to calculate the total number of string which contains the letter A, those will be 5 to the power 3 minus 4 to the power 3, because 5 to the power 3 is the string which contains the letter A or which not contains the letter A, and 4 to the power 3 is which not contains the letter A. So I remove all these string which not contains the letter A. So this basically is a 61. So 61 of these string which will contains the letter A. Our next problem is, we have 7 balls, each of different color, and there are 3 boxes of different shape. How many ways are there to place 7 balls into 3 boxes such that each box contain at least 1 ball? So let's to synthesize this problem and draw a diagram. So in the diagram, as you can see, the procedure or the event is, I have these 7 balls of different color. So 1, 2, 3, 4, 5, 6, and 7 ball. And each ball I have to place in either the box of the shape tetrahedron, or the box with the shape of cube, or the box with the shape of dodecahedron, so I will call D. So each basically ball can go either in T or in C or D. So, or in other words, each ball have three possible ways. So this is the first ball, second ball, third ball, fourth ball, fifth ball, sixth ball, and seventh ball. Similarly, the second ball will have the three possibility. The third ball will have the three possibility. So this is a three possibility, and this ball has three possibility, three. So each ball I can place in three different ways. Since I have to assign each ball, so the conjunction between all these tasks is AND, because I have to assign the first ball, second ball, so on up to the seventh ball. So all the conjunction between these basically to perform this event is AND. Now if I calculate the total number of ways to do these assignment into the three box, it will be 3 to the power 7. So this is the total number of way I can assign 7 ball to 3 boxes. But there is a restriction that one box, each box must contain at least one ball. But 3 to the power 7 is the total number of way you can assign without regarding to this restriction. So what I can do is basically I can assign all the ball. I can assign the first ball in T, second ball in T, third ball in T, and so on up to the 7 ball. So all the ball I can assign in the first box and don't assign any ball into the second and third. So I need to basically remove these restrictions, that when I can place all the ball into the first box, or when I can place all the ball into the second box, or when I can place all the ball into the third box. So these are the number of way basically we need to exclude. Or in other words, basically we need to calculate how many number of way I can place the ball into the second and third, or C and D, but not in T. And I need to calculate also how many way I can place the ball into the T and D but not in C, and so on. So there are a number of other way we need to calculate. The first one is that how many number of way no ball in T. How many way I can place the no ball in T. And as you can see, if I place the no ball in T, that each ball will have only two possibility. Either it can be go in C and D. So it means this will be a 2 to the power 7. That many possibility to place no ball in T. And then no ball in basically C also will be 2 to the power 7. And no ball in D will be 2 to the power 7. So these are many possibility that no ball can go in T, no ball can go in C, and no ball can go in D. So the total number of way is 2 to the power 7 plus 2 to the power 7 plus 2 to the power 7. But there is also commonality between these events, because if I place no ball in the C, I may also, performing this event, I may place no ball in C also. So when I'm placing no ball in T, there is a possibility that in this event I will place the no ball in C, which I already calculated here, or already counted in the second one. So I need to remove that possibility. So this is a one possibility. When I was performing the first event, I may not place any ball in C also, because I have to place the ball in C and D. Is possibility that I place all the ball in D, not in C. And similarly, when I'm performing the event in C, there is a possibility that I will not place any ball in T box. So that I have to remove that possibility also. And similarly, when I'm performing the task in D, I can perform a event which I cannot place any ball in D. you know. So basically I have to place the ball in a C and D, so I have to remove that possibility also. So now this is the total number of possibility that the we will place not in any basically ball in T or in C or in D. So if I remove these possibility from the total number of possibility without a restriction, this gives me the total number of possibility I can place the seven ball into three boxes, and each box will contain one ball. So this will be 3 to the power 7, 2 time, 3 time 2 to the power 7 plus 3, because there was a 3 additional possibility which will I remove, but I need to keep them into the without restriction. So I will basically add them. And if I calculate this total is in the 1806. Here I have one more quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. Also, this is the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.